Okay, so today we are going to talk about writing an equation in two variables to represent a relationship. And when it says relationship, it's talking about between a independent, it's trying to see between an independent variable and a dependent variable. So when it says relationship, it's talking about an equation. So these are synonyms. You have a relationship, or else it's called an equation, or what is the function rule. So you'll have an x value and a y value, and your y value will be your dependent variable. You will get that. It's usually the answer. You'll get that answer depending on what is happening in the expression. So, for instance, you may say y equals x minus 2. Well, this answer depends on what happens in the problem. So, your x is an independent variable, and that just means that it does not rely on anything. If I had 5 cakes and I sold 2, how many cakes do I have left? Well, 5 won't change. 5 will always be 5, but y will change depending on what I did to the 5 in that expression, creating that equation of 5 minus 2 is 3, or if I made 7 minus 2, this answer would change. And we'll talk about that in just a minute. So let's look at number 1. We are in lesson 22, session 2 of the iReady. So Brian runs 7 kilometers each day. Write an equation that models the total kilometers, K, Brian runs over D days. So first of all, let's make sure we define what these variables mean. So D is over the days. D represents the days, and K represents the total kilometers. Brian runs 7 kilometers every day. Write an equation that models the total. So each day he runs 7. So if he did Monday, that would be 7. Tuesday, he would do 7. Wednesday, he would do 7. So what am I repeating? 7 equally. Well, what's repeated addition? Since it's a total, it's multiplication. So I know 7 won't change, but what affects my 7? The number of days. One day, do you just run one day? Do you run 3 days? Do you run all 7 days? So the days is what I need to know. That will be my independent variable. The answer will depend on what D is. So my total kilometers ran will depend on what I do in my equation. So when it tells me to write an equation, here's my equation. My total miles would equal the 7 kilometers for every day. I just don't know how many days he ran. Number 2, a pool designer constructs a frame for an in-ground pool. The width of the border of the frame is F, so F is the width of the border. It's greater than the width of the pool, P, so P is the width of the pool. Write an equation that models the width of the border frame with respect to width of the pool. Well, didn't it say that the frame is, remember is equals, is 75 feet greater? How do we write 75 or 0.75 greater? Plus 75 than the width of the pole. Well, what was the width of the pole? P. So F is 0.75 feet greater than the pole. And that would be my equation. Now, if I was given any numbers, like if I was given P, I could solve. If I was given F, I could solve. Let's look at number 3. To rent a car, there's a flat fee of $50 plus $32 per day. Per day, how many days? I don't know. Maybe they'll tell us. Write an equation that models the total cost, C, total cost for renting the car for D days. All right, so since it says write an equation that models the total cost, isn't that usually your answer? So I'm going to put my answer first. C should equal what math I'm doing in my problem. So $32 per day. So one day it's $32, the next day it's another $32, the next day it's another $32. Repeated addition, that is just my multiplication. So I know it's $32 per day. I just don't know how many days. And then I have to pay $50 regardless. For one day or for 12 days, I have to pay that constant price of $50. So I'm going to add my $50. And then that is my equation. The total cost. If I have $32 per day and say it's 10 days, well, that would be $320 I spent plus the $50 that I had to pay for my flat fee. That would give me the total cost. So I know that is done correctly. All right. Franklin is traveling with his family on a road trip. The table shows the number of miles, M, number of miles, traveled over N hours, so number of hours. Write an equation that models the total distance traveled with respect, so the total distance with respect to the time traveled. So when you are looking at this, it says write an equation that models the total distance with respect to the time traveled. So you need to figure out what's the relationship between this. How did I turn a 2 to a 130? Well, whenever I have a table, then I want to make sure that I prove whatever I think it is at least 3 times. If I add 128, that will give me 130. But remember, I have to be able to plug in any number, and it always give me the same ratio or the same result that I would get in any number that I plug in. So if I'm adding 128 here, I should be able to add 128 to each of these and get the distance. Well, if I say 128 plus 3, is that going to give me 195? No, that's going to give me 131. So I know it can't be an adding 128. What's another way that I could turn a 2 into 130? Well, I'd multiply a number. If I don't know the factor, then I can divide 130 by 2, and I should get 65. So if I multiply 2 times 65, does it give me 130? Yes. If I multiply 3 times 65, does it give me 195? Yes. If I multiply 5 by 65, does it give me 325? Yes. So I have proven it at least 3 times. I could have chosen any of the 3 to prove it. And then I have enough information to write my equation. It says that models the total distance. Well, the total distance would be M. That would equal whatever I am doing in my problem. And what am I doing? I am multiplying 65 times n. And now, if I substitute 2 in there, 2 times 65, that would give me 130. If I substitute 7 in there, 7 times 65 would give me m. So this is my function rule, or my relationship between the hours and distance. Great. Let's look at number 5. Gracie can type 240 words in 6 minutes. Based on her typing rate, write an equation that can be used to predict the number of words. Gracie can type in n minutes. Number of minutes. So when it's telling me, explain how you found the answer. Okay, so when I'm trying to write a rule, when I'm trying to show that relationship, when I'm trying to write that equation, I like to put it in a table. So when I have, words to minutes? So I would say words to the minutes. And what did they give me? They gave me 240 words for 6 minutes. However, if I wrote how did I get from 6 to 240? What did I multiply 6 by to get 240? If I don't know that factor, I can divide it. And I would realize that I am multiplying it by 40. So since I don't have several numbers to double check, I'm going to have to assume that this is my rule. And I have total, which would be my W, equals, and what did I do to n? I multiplied it by 40. All right, let's look at number 6. A little league hits the ball approximately 15 times in 15 innings. Write an equation that can be used to predict the number of hits the team has after n innings. So hits, n is innings. If I do a little table, hits to innings, and I show it's 15 to 5. How did I turn my 5 into 15? I multiplied it by 3. So when I write H for my answer, how did I do that? H, I'm going to have 3 times whatever n is. And I could put other numbers in. So say I had a 4 and a 1. 3 times 4, wouldn't that give me 12? And 1 times 3, wouldn't that give me 4? So that would be the rule for those numbers. Delilah babysits a fixed number, that's your independent, of hours per week. Her friend Laura babysits 5 hours more per week than Delilah. So this is Delilah's hours. And then what did it say? Her friend Laura babysits 5 more hours. So D plus 5 is Laura's hours. Write an equation that models the total number of hours Laura babysits. Oh, and we just did it actually. Laura's hours, isn't it D plus 5? But since we're writing 2 equations, let's just write L for Laura equals Delilah's hours plus the 5. And you could have used any variable you wanted. See that? All right, number 8. A graphic designer is making a logo using rectangles with the height to width ratio of 4 to 5. So I'm going to do height to width, and it is a 4 to 5. Write an equation that can be used to find the height of the rectangles when the width is known. So when I know this, say it's 2, how do I figure out the height? So what do I do to my width to get the height? Well, 5 times or divided by something would give me 4. Let's do 4. Let's just do 4 divided by 5. 4 divided by 5 would give me 0.8. So aren't I multiplying the 5 times 0.8? And that would give me 4. Because it says write an equation that you can use to find the height. Well, if I'm trying to find height, height's my answer. I want height. What did I do over here to get that? So I can say I multiplied 0.8 by the width to figure out what W was. And if I did that too, I just put in a different number. If I did 2 times 0.8, I would figure out that's 1.6. So I should be able to use this equation to figure out any unknown number. Number 9, one subject notebooks cost $3.60 for $6 and $5.50 for $10. Is it possible to write one equation, meaning one rule, all of these are your function rules, to find the total cost for notebooks? So let's do a cost for notebooks. And here it was $3.60 for 6. And this one was $5.50 for 10. So if I do cost equals something times your n, because the numbers get bigger, what am I multiplying with n? Well, if I divide 360 by 6, I would be multiplying this by 0.6. So this right here would be a 0.6 times n. If I multiplied something by 10 to get 550, that would give me a 0.55. So I would write that equation or that rule as C equals 0.55 times the number of books. So is it possible to write one equation? No, these are two different equations.